So in this figure, E is given to be the midpoint of ED. You need to prove two things. First thing is you need to prove that G is the midpoint of BC, and you need to show that twice EG is equal to AB plus CD. Let us try to draw this rough figure here. What kind of a quadrilateral is this? Can you tell me what kind of quadrilateral this is? Anyone?
Trapezium.
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 Exactly, because two sides are parallel. So these three are given to be parallel. Okay, and this is joined with the help of a dotted line here. This is your F, E, G. This is given to be the midpoint, so therefore these two lengths must be equal. Okay. Okay. So three lines parallel, EB, DC, and EG. Parallel, given E as the midpoint of ED. First question, you need to show that this G here is the midpoint of this. That means you need to show that this length is equal to this length, right? That is what the idea is. So let's see how to show that G is the midpoint here. So let's see how to show G is the midpoint. First of all, consider this triangle ABD. This triangle. Consider this triangle. In this triangle, what you see here is that E is the midpoint of AD, right? Also, this length EF joining the two sides of the triangle is parallel to this side AB. That means which conditions of which theorem are applicable? Midpoint theorem or converse of midpoint theorem? Which one? How many midpoints given here? Only one midpoint given, right? But in midpoint theorem, how many midpoints should be given to you?
Two.
Two midpoints. Here I have only one midpoint. That means obviously the converse has to apply, because what are the two conditions? E is the midpoint, one midpoint is given, and lines are given parallel. These two lines are given parallel. That means by the converse of midpoint theorem, if you apply the converse of midpoint theorem in this red triangle, then you can say that F is the midpoint. Can you say or not?
Yes, sir, we can say.
Yes, sir.
In triangle ABD, E is the midpoint of AD given. And what else is given? EF parallel to AB. Therefore, F is the midpoint of BD. This is why what? By the converse of midpoint theorem. Okay. So we have proved F is the midpoint. Now look at this triangle. Once I have proved that F is the midpoint, now look at this blue triangle. This triangle. In this triangle, what do we know? We know that F is the midpoint, as we have proved here. Okay. We know that G is the we don't know G is the midpoint, right? So we know that FG, this line, is parallel to this line, right? So again, if we apply the converse in this triangle, blue triangle, can we say G is the midpoint?
Yes, sir.
F is the midpoint here. Okay, this F is the midpoint, and this straight line is parallel to this straight line. Therefore, by the converse of the midpoint theorem, I can say that the G is also the midpoint of BC. So now, same thing we are going to write here in triangle BCD. F is the midpoint of BD as proved above. And what are the lines? FG parallel to DC. Okay, this is given. Here also you write given. Therefore, G is the midpoint of therefore G is the midpoint of BC. Okay, so the first part is over. Proved. First part is over. Second part. Second part says you need to show that twice EG is equal to AB plus CD. What is the length EG here? See, this green line is your EG. And remember that you have already shown that E is the midpoint of AD and G is the midpoint of AD. So what we do now here is, in order to prove the second part, since we have already proved that E and G are midpoints, we'll construct a triangle such that E and G are midpoints of the sides of the triangle. How can I construct the triangle? What I do here is, from C and E I join C and E, and then I produce it. And then I produce AB also until they meet. Now you see this triangle here, this big triangle. Let us call this point P. Okay. If you see this big green triangle here, if you see this big green triangle, can you see that E and G are midpoints of the sides of the triangle? Can you see?
Yes, sir.
That is why we construct this green triangle. Okay, this is the main idea of the problem. We construct this green triangle such that E and G are midpoints of the sides of the triangle. Otherwise, we'll not be able to show that twice EG is equal to AB plus CD. That is the main idea here. In order to show, you will have to construct this triangle such that E and G are midpoints of the side, because we have already shown E and G to be the midpoints. Okay, so what you do here is you write.
Excuse me, sir.
Hmm.
So over here, E is the midpoint on PC.
E is the midpoint of AD. E you have already shown to be the midpoint of AD.
No, sir, I'm talking about the triangle.
Hmm.
So in triangle, E is the midpoint on PC.
No, actually what happens is that I don't know whether I have shown it here or not. No, I have not shown it here, I think. Hmm. The point here is that once we have drawn this triangle, I think I skipped this part, a small part here. Okay, I think I have skipped a small part here. Okay, and that part is that you have to show that these two triangles are congruent. This triangle and this triangle. These two triangles. You have to show that these two triangles are congruent. Only then you can say that E is the midpoint of PC. Sorry, I skipped that part. Okay, in the solution, I have skipped that part. So you do it this way. Let me just erase these two so that it is convenient for me to see. So you construct, you first of all, you that big triangle you construct, you produce CE. So you write here join CE and produce it to P, where P is the point of intersection of CE produced and BA produced. Okay. So now we are going to prove that these two triangles are congruent. In triangle AEP and triangle DEC. How can we prove that these two triangles are congruent? Can you tell me? These two are vertically opposite angles, right? Write this angle AEP is equal to angle DEC because they are vertically opposite angles. Okay. Next, this angle must be equal to this angle. Why? Because they are
Alternate angle.
Angle EAP is equal to angle EDC, alternate angles. And what else? If you see that this DE is given equal to this, that means ED is equal to AE. In fact, EA, because we have written triangle AEP first, let us write EA first. EA is equal to DE. So therefore, these two triangles are congruent. Therefore, triangle AEP is congruent to triangle DEC. Okay, and this is by what axiom? By what
Angle
axiom?
side angle.
ASA,
Yeah.
because ASA axiom. Okay, so these two triangles we have proved congruent. Now, once we have proved congruent, what can I say? I can say this length AP must be equal to CD by CPCT. I can say or not? AP is equal to CD. Just look at the figure and tell me. Can I say AP is equal to CD? These two. Because see, these two angles are equal, vertically opposite angles. And opposite to this angle is this side. And opposite to this angle is this side. They must be equal. So this is by CPCT. Now once I have proved equal, also I can say that this length PE must be equal to CE. Again, this is by CPCT. PE is equal to CE. This is by CPCT. Now what does this mean? This means P is the midpoint of what? PC. Not P, sorry, E is the midpoint. E is the midpoint of PC. Can I say or not? If these two are equal, then I can say that E is the midpoint. Right? So now what I have done is I have shown that E is the midpoint of PC. Now what am I going to do? I have shown that E is the midpoint. Now I'll apply my midpoint theorem in this triangle, this big triangle here. This is the midpoint. This in this triangle we are going to apply the midpoint theorem. E and G so say in triangle PBC, E and G are midpoints because G we have already shown to be the midpoint. E and G are midpoints of PC and BC respectively. Therefore, what can I say? What can I say? EG parallel to PB. That is obvious, right? Because that is given actually. EG parallel to PB. And what can you say? EG is equal to half of PB. But what is PB? What is this length? This length is equal to PA plus AB. So instead of PB, you can write PA plus AB. Now, what is PA? What is this length? By CPCT, I have already shown that AP or PA must be equal to CD. So half of CD plus AB. Right? So I have brought AB and CD into the picture. That is what we have to prove here. Twice of EG is equal to AB plus CD. So I am getting EG is equal to half of AB plus CD. Therefore, AB plus CD must be equal to twice of EG. And that is the required proof. Okay. I seem to have skipped the congruency part here. Okay. So please do this congruency part. That was my mistake while making the notes. Okay. Anyone who could not understand any part? If you understand this problem, you have understood the next problem also. Tell me. No one.
Yes, sir. Understood, sir.
Number 5. In this quadrilateral ABCD, it is given that AB and DC are parallel. What is different in this problem is that E and F both are given to be the midpoints. Compare it with the last problem. You will see that in this problem, E and G both are given to be the midpoints. E and F both are given to be the midpoints of AD and BC. Okay, the non-parallel side, AD and BC. You need to calculate EF given AB and the length of AB and DC. Also AB given DC and EF. So this is also a very, very similar problem to the problem that we did just now. Okay, let's draw this figure. Okay, so E and F are given to be the midpoints. This is a quadrilateral in which two sides are parallel. Again, this is a trapezium actually, where E and F are the midpoints of the non-parallel sides. You need to calculate the length of EF given AB and CD. These two lengths are given. That means just as in the previous problem, you need to find a relation between these three sides, the side that I have marked. Okay. So let us find it once again. How to, but this time a little different because E and F both are given to be the midpoints of the sides. Okay. Now we proceed exactly similarly in this problem also. What we do here is you construct E and F, since E and F are given to be the midpoints, you join CE and produce it to a point, say P, such that when I produce AB and complete this triangle, so that now see that in this triangle, this green triangle that I have made, this big green triangle, just like in the previous problem, in this big green triangle, you have E and F as the midpoints of the sides. So therefore, what can I say? Produce CE and BA to meet at P. Okay. So now in triangle PCB, what can I say? E and F are midpoints of what sides? No, again, E is not the midpoint of PC. Okay. So you have to first prove that these two triangles are congruent. Which two triangles? These two triangles. Not this side. My mistake. This triangle and this triangle. Right? You can prove just as I proved earlier. Okay. That is triangle CED is congruent to triangle. Congruency part I'm not proving because I've already done it. I think there's something wrong. Give me a minute. So PEA. This you can prove by ASA axiom. Okay, just as we